Find the power series representation for the following function. Also find the interval of convergence. So our function is given x over 1 plus x quantity squared. And we know that the power series for 1 over 1 minus x is given by sum xn, n from 0 through infinity. And this is valid for x, absolute x less than 1. So basically we know for the power series of 1 over 1 minus something, but we have x over x 1 plus x squared. In fact, we can rewrite this in this way. This is same as x times 1 over 1 plus x quantity squared. Okay, so first we want to find the power series for 1 over 1 plus x quantity squared and later multiply by x. And we have a square. We know how to write the power series for 1 over 1 plus x. Okay, what we can do is 1 over 1 plus x is same as 1 over 1 minus negative x. Now this is in the form of 1 over 1 minus something x. So 1 over 1 minus something. That is given by sum n from 0 through infinity, that whatever we have here that raised to n. So we have negative x, so it will be negative x raised to n, comma, and same thing x less than 1, in our case absolute negative x less than 1. And we can do some work further simplifying here, n from 0 through infinity. Negative x to the n is same as negative 1 to the n and x to the n. This is producing plus minus sign. So we are basically getting alternating series, and absolute value of negative x is same as absolute value of x less than 1. So if we have 1 over 1 plus x, then we have this power series. But the question here is 1 over 1 plus x squared. So how can we convert 1 over 1 plus x to 1 over 1 plus x squared? We can multiply this by itself, but multiplying two power series is very difficult. Okay, let's not go for that. Let's find the derivative of 1 over 1 plus x. Okay, what are we gonna get here? Let's say derivative of 1 over 1 plus x is in fact using quotient rule, or we can take 1 plus x quantity raised to negative 1 on the top, same thing, or use quotient rule. We get on the bottom 1 plus x quantity square, and we get 1 on the top, negative in fact, times from chain rule derivative of 1 plus x, which is 1, or you can use quotient rule. At the end it will be negative 1 over 1 plus x quantity square. Okay, here's a success. So derivative of 1 over 1 plus x is in fact negative 1 over 1 plus x square. So to find the power series of 1 over 1 plus x quantity square, in fact we can multiply both sides by negative. So if I multiply here and there by negative, so this implies 1 over 1 plus x quantity square is in fact, we can put negative here, negative derivative of negative 1 times in fact 1 over 1 plus x. So to find the power series of 1 over 1 plus x quantity squared, we find the power series of 1 over 1 plus x, and here you go, 1 over 1 plus x is here, and find the derivative, then multiply by negative 1. Okay, then we will get the power series of 1 over 1 plus x squared, this part. Then finally we multiply by x to find the power series of this. Okay, this is just the background, or basically this is it. So what I would do here, note that derivative of 1 over 1 plus x, in fact negative 1 times derivative of 1 over 1 plus x is 1 over 1 plus x quantity square. Okay, so this is equal to that. So let me write other way around. So I want to write this to the left side, that is 1 over 1 plus x quantity square is equal to negative 1 times derivative of 1 over 1 plus x, which can be written as 1 over 1 minus negative x. Okay, so I'm writing this over here using the base formula. 1 over 1 minus x is this sum. Okay, so this is same as negative 1 times derivative of 1 over 1 minus something. 1 over 1 minus something is sum, that something x to the n, in our case negative x to the n. Okay, and n from 0 through infinity, and this is true when that something x less than 1, in our case absolute value of negative x less than 1. So let's continue this. Negative 1 times, let's simplify inside and we take the derivative. This is n from 0 through infinity. Negative x to the n is same as negative 1 to the n x n, because negative x is same as negative 1 times x. So negative 1 times x, and absolute value of negative x is same as absolute value of x less than 1. Negative 1 times, let's take the derivative. So this will be term by term derivative. So basically we take the derivative of xn. So this will be sum n from something through infinity, 0 through infinity, but I'm going to change that in a moment. Negative 1 to the n, derivative of xn is power rule, n x n minus 1. We were supposed to write n from 0 through infinity, but for n equals 0 we get very first term something times 0 times x, so it will be 0. So we start from n equals 1. So when we differentiate, so the derivative should be the sum should be started from 1, or even if you write n equals 0, it's not wrong, but the very first term, if you write n equals 0, that means you are writing additional term 0. Okay, now we need to multiply this by negative 1. Basically negative 1, move this inside. Okay, we can write here negative 1 1 copy, negative 1 n many. So when we multiply we add the exponents. So this will be n from 1 through infinity, negative 1 raised to 1 and n plus 1 times n x n minus 1, and this is valid when absolute x is less than 1. So we found the power series for 1 over 1 plus x square, but our original question is x over x plus 1 plus x quantity square. So we found for this. Okay, now to find the power series for fx we need to multiply by x. So we go down here and we multiply by x to get the final answer. Then for fx, which is x over 1 plus x quantity square, that's x times 1 over 1 plus x square, which is here, x times n from 1 through infinity, negative 1 to the n plus 1 times n x n minus 1, and interval of convergence is here. Now let's multiply. So this x can be multiplied with this x raised to n minus 1. X means x raised to 1 and x raised to n minus 1. We add the exponents. Okay, so the final answer is n from 1 through infinity, negative 1 raised to n plus 1, n x raised to n minus 1 plus 1, just n. And this is valid for absolute x less than 1. This is same as negative 1 to 1. Okay, final. So this is the interval of convergence, and this is the power series for the given function x over 1 plus x quantity square. Final.